Hello friends, in today's video, let us try to understand the photoelectric effect. The photoelectric effect was observed by Hertz in 1887. So he observed that when light of suitable frequency is allowed to fall on certain metals like sodium, copper, etc., electrons are emitted by these metals. This effect was termed as photoelectric effect because the light is inducing the emission of electrons in these metals. This phenomenon was studied extensively under various experimental setups. Let us try to understand one of the experimental setups that was used to study the photoelectric effect. So here you can see an experimental setup. So this here the plate A on the left side is the photosensitive metal. On the right side we have metal plate B. This plate acts like the collector of electrons. A and B both forms two electrodes to which a variable power supply is connected. Here an ammeter is present to detect current, and during the experiment, light of suitable frequency is allowed to fall on to this photosensitive metal. So due to photoelectric effect, you know, electrons will be emitted by the photosensitive plate. The electrons are actually have the freedom to move to any place. But since here we have a B plate which is at a positive potential, it will be attracting the electrons to that plate. So the electrons will be reaching the collector plate and will be moving towards the cell, constituting a current called photoelectric current. So as you can see, if light is allowed to fall on a photosensitive metal, then current is produced due to the photoelectric effect. This phenomenon, experimental phenomenon, the photoelectric effect, was studied under various conditions and a lot of observations was made. So as you can see, one experimental arrangement was to vary the potential of B, the collector plate, and study what is the difference on the current and other values. So as you can see, the positive potential of the B plate is what attracts the electrons towards the right side. If you increase the potential at B, the positive potential at B, what will happen? Still the electrons will be able to reach the B plate. Would the potential at B, if increased beyond a particular value, would that make any change on the current? No, because the electrons are emitted by plate A depending on the incident light. So it was observed that if the positive potential is increased beyond a particular value, the current is not increasing. So there is one saturation current, the photocurrent, where a saturation happens. Now the potential at B plate was decreased and studies were made. It was found that when the potential at B decreases, the photocurrent is also slightly decreasing. And if you decrease the B up to a 0 value, suppose I am decreasing the positive potential at B and making it into 0 potential, still some electrons was able to reach the B plate and hence a photocurrent was obtained. So then the experimentalists tried to make the potential of B plate negative. What will happen then? The electrons that are produced by the photoelectric effect will try to move to right side, but the negative potential at the B plate will be repelling those electrons and they cannot make it up to the right side. So as you can see, if the potential at the B plate is made sufficiently negative, then the electrons cannot make it up to the B plate. So there is one potential called the stopping potential, the stopping voltage or the cutoff voltage. And if you apply the stopping voltage, which is a negative voltage at the B plate, no electrons can move up to B because that voltage is sufficiently high to repel all the electrons. And that is one of the experimental observations that was made. For example, in the case of sodium, this cutoff voltage or stopping voltage is 2.3 volt, and in the case of copper, this stopping potential is 4.7 volt. So this is one of the experimental observations that was made with regard to the potential at point B. The stopping voltage or the cutoff voltage is there at which no electrons can reach the B plate and no photocurrent is obtained. Then the experiment was continued with many other criteria and parameters. Plenty of interesting aspects related to photoelectric effect was obtained through experimental analysis. So it was found that the photoelectric current or the photocurrent depends on 4 factors. First factor is the frequency of incident radiation. Then the intensity of incident radiation. Then the potential difference between the electrodes. That factor we have already seen. We saw that the potential difference between A and B will be playing a factor when it comes to the value of photoelectric current. Finally, the nature of the emitting substance. As we have seen, different metals will be behaving differently under photoelectric effect. For example, sodium and copper have different behavior, and the nature of the material is important when it comes to the photoelectric current. So when detailed studies were made to analyze photoelectric effect, some of the observations that strike the scientists were: first observation is the observation of a threshold frequency. As we have already stated, frequency of the incident radiation is an important parameter when it comes to photoelectric effect. So it was found that not all light of all frequencies could induce photoelectric effect in a metal. Only light with frequencies higher than a threshold frequency nu zero. Frequencies higher than a threshold frequency is able to make emission of electrons or photoelectric effect. So this is the first observation that strikes the scientists. There is a threshold frequency which is the cutoff frequency, and if the frequency of the light is lesser than this threshold frequency, no photoelectric effect is observed. Frequency must be higher than the threshold frequency for photoelectric effect to happen. Then the second important observation that was made, that kinetic energy of the emitted electrons, it actually depends on the frequency of the incident radiation. So if a particular frequency light is falling on metal A, if the frequency is higher than the threshold frequency, electrons will be emitted with a kinetic energy. And if the frequency is increased, a higher frequency light is made to fall on this metal plate, the kinetic energy of the emitted electrons is found to increase. And this kinetic energy does not depend on the intensity of the incident light. It depends only on frequency. So that is the second assumption that was obtained by experimental observations. Then the third important observation was that the stopping voltage increases linearly with frequency. So we have already defined stopping voltage. Stopping voltage is the potential that is required for stopping all the electrons, or the voltage at which no current is flowing, or the voltage at which no electrons will be reaching plate B. And the stopping voltage Vc, the cutoff voltage, is found to increase with frequency, and it does not have any effect on the intensity of the incident radiation. The intensity does not affect stopping voltage. The frequency determines the stopping voltage. And the fourth observation that was obtained by experimental analysis was that the number of photoelectrons or the photocurrent depends on intensity and not on frequency. That means even if you increase the frequency, we have seen that the kinetic energy of the electrons will be increasing and the stopping potential will be increasing, but the photocurrent will not be increasing if you increase the intensity. And finally, the fifth assumption was that no time lag for photoelectron emission is observed for photoelectric effect. When the light falls on the metal, instantaneously the electrons are being emitted. So these are the observations that we get from analyzing a photoelectric effect experiment. And the theories that were existing then, the classical theories for understanding the physics of light, the wave theory, assuming that light is a wave, was not able to explain all these specific features. A satisfactory explanation could not be made by these classical theories. Hence, it was required for an improved explanation for this theory, this photoelectric effect. And in 1905, Einstein came up with a simple explanation for this photoelectric effect based on Planck's quantum hypothesis. So in the next video, we will understand this photoelectric effect based on Einstein's quantum theory, Einstein's explanation based on quantum theory. So let me also explain one of the graphs related to the experimental observation. So here you can see in this graph, along the x-axis, we are actually plotting the collector plate potential, the voltage applied between the plates A and B, and along the y-axis we are observing the photocurrent. So as you can see, if you increase the potential, the photocurrent will be slowly increasing and will be reaching a saturation value. So this is the first result that we have discussed. We have earlier said that if you increase the potential between A and B beyond a particular value, then the photocurrent will reach a saturation value. And the final parallel lines here represent the saturated value of photocurrent. So here you can see the photocurrent is getting saturated. If you increase the potential beyond that value, beyond a particular value, there is no increase in photocurrent. But when you decrease the potential, you can see the photocurrent is dropping, and even at zero potential, here you can see this is the zero potential point. Even at that point, we have some value of photocurrent. Now in order to reduce the photocurrent, still we have to increase the potential at B with negative values. We have seen that we will be applying negative values of potential at B, and hence at one particular value of voltage called stopping potential, if you supply that negative potential at B, then the photocurrent will be 0. So that is the implication of each of these curves. Now here three curves are drawn and three curves correspond to three different intensities. So as you can see, I1, I2 and I3 are three intensities of light, and with intensity you can see the photocurrent is increasing. Higher intensity means higher photocurrent. But frequency does not have any say in the photocurrent. We have already seen that frequency and kinetic energy of the electrons are related. Kinetic energy is related to frequency. Then the stopping potential Vc is related to frequency, and the photocurrent depends on intensity and not on frequency. So these are the correlation. Kinetic energy of the electrons depends on frequency and not on intensity. Stopping potential depends on frequency and not on intensity. Photocurrent depends on intensity and not on frequency. So here you can see for various values of intensity, stopping potential is one and the same. So these are the specific experimental observations that we get from the experiment of photoelectric effect. And the classical theory or the wave theory of light was not able to account for these results. It was from the Einstein's explanation based on the quantum theories that these observations was sufficiently and satisfactorily explained. In the next video, we will be discussing how these observations came based on theoretical factors. I hope this video is clear for you. Thank you.